Recording. Well, again, good morning, everybody. Thanks for joining us today as we go through this conversation of devil in the details, a look at air barriers. For those of you that are new to our program or to our program, like as if my name is Josh Harmon. I represent the Minnesota Energy Code Support Program, which is a program facilitated, sponsored by the series of utilities listed there below that represent the state, and really to support and educate, provide resources, trainings, and those types of things for communities throughout the entire state of Minnesota to assist in the construction of energy efficient buildings. And so this is a free webinar. This is a free resource to any community, and we'll talk about some of the things that we do. If you have any questions, feel free to check out our website, www.minnesotaenergycodesupport.org. Try saying that 5 times real fast. And you'll be able to find some information, both technical resources that we start to develop and we're putting forward. Probably have a few more of those to unveil here at the next meeting in person. We do host a monthly, usually the last week of the month, a monthly in-person training. It's usually a 4-hour training. It's free. We are moving it around the state to different Minnesota Department of Transportation districts. And so our next one is going to be in Monticello at the end of July 31st. Our following one will be in August, I believe it's the 27th in Fergus Falls. So again, if you have opportunity, feel free to invite your building officials, your contractors, design professionals, and architect and plans examiners, right? The entire building team should really be a part of it because we found that at least it's easier to get compliance when we're all on the same page as what compliance looks like, right? And so if you have any questions, please check out our website, send us an email, and we'll get back to you as quickly as we can. Generally, as a general rule, one of my principal themes of most of the courses that I teach is a belief that if we understand the why of a process or project problem, we can figure out the how. And in that context, the same applies to building codes, right? We're looking at why do we have building codes? We have building codes to provide that basic uniform performance standard for construction within the state, right? We want buildings to perform at a certain level, a minimum level of safety, structural stability, energy efficiency, affordability. All those concepts get rolled into construction codes. That's why we develop construction codes, is to guide and understand what are the minimum expectations for safe buildings, and in the context of we're talking commercial this week, safe buildings to occupy or even to reside in, depending on the situation. So again, how do we build safe minimum buildings, and then how do we move forward with doing that on a holistic approach that applies to the entire region, and so we don't have some areas that do one thing, some that do it different. The same applies to the energy code. The energy code is really to serve as that force, that guidance on how we design and construct buildings with a mindset towards energy utilization, heat loss, climate control. The real thing about codes, in my experience, and I've been around probably as much as many of you have, the reality is codes are all about control, right? We try to control how load is transferred through a building. We try and control how air flows through a system or through a design. And that's what we're trying to do here. We're trying to control how energy is used in a building, whether that's through traditional heating and cooling, or if we're talking about lighting and power. We're really thinking about how those buildings operate. And we understand that the code, and I'm going to try and go through this real quick. The code applies to new buildings. It applies to portions of new buildings that get it, so like additions, alterations, new equipment, historic buildings follow under some of the components here. The alterations, change of occupancy. So when we think about how a building changes over time, that's when we really need to evaluate how does the code apply. So again, we understand it does apply, but how does it apply? How does it come into? How do we bring a property into compliance with the energy code? And really think about it this way: when we build buildings, we build them for their lifetime, right? We think about some of the components we'll talk about don't generally get changed in the process of a building's life, right? If you think about it, I like to use simple examples. And so if we use a simple example of maybe a gas station or a convenience store, the exterior walls typically aren't going to change. You may change out equipment from time to time. You may change out lighting fixtures, and depending on what you're doing, you might even change out some windows once in a while. But as a general rule, the concept of the building, the size, the building thermal envelope generally stays the same. And so part of this process is really understanding how that works and how we evaluate buildings for their long-term sustainability. What this code does not address is going to be those single family and two family dwellings, townhouses, and those IRC 1 through 4 buildings, and that are 3 stories and less, right? And we'll talk about those later in the year when we get to that point. But really, we understand what it applies to, what it doesn't apply to, and when we think about the energy code, when we're evaluating a project like a convenience store, we're going to be looking at certain controls and efficiencies that address the key 4 components that I find most directly affect energy efficiency. And that's going to be, again, my building thermal envelope, my mechanical systems. Now, building thermal envelope is going to integrate in this concept of air barriers, which we're going to talk about today. The mechanical systems, the surface water heating systems, the power and lighting, and different equipment, right? So as we think about how we design a building and we think towards code compliance, we're really evaluating all these components. And the code provides us a very specific manner for understanding that, right? We're utilizing, for those of you that aren't already aware, the energy code is a local modification of the ASHRAE 90.1 2019 standard, and incorporates the 11 chapters and sections, and as well as the 3 appendices that you see there. And so when we think about enforcement of this code, the code tells us in chapter 4 that there are certain expectations of what we should have on a construction document. Remember, when we think about construction documents, that's the document that we should be able to give to any contractor, and they should be able to move forward with the project. Reality is contractors change, life happens to people, and so we need to make sure that those construction documents are literally the blueprint by which we build, right? And so I shouldn't have to have questions of, well, it's in the architect's going to tell me this later, or it's how is the builder going to do this? No, it should be written down so that we're aware and we can verify that we're not doing, as much as I hate doing, and I've done it, we've all probably done in-field plan review, but that's not the point. We want to make sure as much as possible we have all the information at the beginning of the process so we can move forward efficiently and make a project successful. None of us want to see failure in our communities. We want to make sure things are successful. And one of the things that we recognize that these 18 items and this Devil in the Detail series is really going to kind of highlight is the concept not only of compliance paths, but air sealing details. It makes no, it's illogical, makes no sense. It's illogical to build a building and put a lot of emphasis into the wall design and put it into the mechanical systems, and then to say, but you know what? I don't care if it leaks like a sieve. I don't care if there's no control for the air we generate, right? We build a wall to separate the environment from the interior conditioned space. We build a mechanical system to control and to temper, to condition the air within that environment. And then we say, just let the windows and let the doors do what they want. The classic phrase I always love is, you weren't raised in a barn, right? And so that's really what we're getting at. And it's one of those things that in our Devil in the Details series, what we're really looking at are what are those things that sometimes get lost. And what is that detail that sometimes is missing and really can be the devil that makes a project fail, that makes a project not as efficient or as effective or successful as what we were looking for. And again, not everything is directly ties back to the code. Sometimes it's a question of, as a project owner, as a building owner, I'm expecting a certain level of cost for annual operating expenses. And if I have air leakage that's uncontrolled, then I'm going to have a much different bottom line when it comes to operating expenses. And then I'm going to be mad at everybody, right? The reality is I'm not just going to be mad at my design professional. I'm going to be mad at my contractor. I'm going to be when I'm going to be mad at my building department, because all of us really in the real world get tied into this group of people that are involved in project development, right? And so we want to make sure that we keep the best possible buildings for our community and expectations within our, and really the standard by which people reference or see our industry. So again, that's what we're looking at today, is really how does the air barrier get defined, and where are the things that we see lacking? Now, very quickly, we understand that compliance paths are huge to understand, right? And that's going to drive a lot of the thermal envelope calculations and design components. And so in the design of buildings, and I'm not going to read all these, I'm just going to click through them real quick. I'm going to draw your attention to the three colors, right? The yellow, the green, and the blue. And what that's telling us that is in a new building, we're going to have three options for compliance. We're going to have the list of sections that we see there, which is what I typically call prescriptive, right? Follow the book and do what the book says. The green is going to be section 11, the energy cost budget method, and appendix G, which is going to be our performance rating methods. So again, what we're really looking at when we build a new building is we're going to have to identify which of those three are we looking at. Follow the book, calculate the energy cost, or figure out a performance measure and compare it to a design, right? And whether we look at all of the different components, right? Well, let me get out my handy dandy laser pointer. We see all the different components of a project we talked about earlier in scope. When we go through, we notice, and this is this is just reminding us that this is going to comply to new construction without requiring the unaltered space to comply. That's one of the state modifications. But again, you see the same three items, right, in the color scheme. That existing buildings, historic buildings, shall comply with to the greatest extent possible. So that's where we get a little bit of that exception for historic buildings. We see it again in change of use, where we have a historic buildings reference. We have tenant spaces, and again, we're seeing that same green and blue. So what we're really seeing is reduced in my simple ways, reduced to three compliance paths, right? We saw that in every one of those, and you'll get these handouts and you can go back and read through them all you want at a time that may be appropriate. So the question that we have in the chat is, can we mix and match the three compliance paths? And the answer is no. No. Now, what you will see, and when we talk a little bit more about the compliance path, the prescriptive compliance paths, there's actually within it three compliance paths itself, because of, we're looking at R values, U factors, and total UA calculations. But you cannot, you pick one or pick the other. You've got to declare a compliance path and follow that path. And now what you'll see is in some of these compliance paths, you'll be going back to those standards to figure out how certain things work, right? There's going to be mandatory components that are listed in each one of those sections, but not necessarily the prescriptive requirements. Oop, what am I doing? Move my mouse. Stinking mouse. There we go. So when we're thinking prescriptive, you're going to follow all the requirements of these specific sections within the code. When we go to total building performance, energy cost budget calculation, what we're doing is we're really looking at that structure, and instead of saying the table says this, do this, right? We're saying build the building with some basic understanding of building science and minimum backstops, but really, how is that building going to perform? We're comparing in our examples here, two convenience stores, one built completely to the prescriptive process and one the way you want to build today. And we're going to see which one is going to count, how much is it going to cost to operate both of those on an annual basis. And then you're going to come to that energy cost calculation says, I'm going to compare those two annual cost values and say, this one equals or is better than the standard design. My proposed design is equal to or better, and therefore it passes. And whatever I put in that package that makes that project has to be now the rule I follow. So and again, and we'll get into this, we've done this conversation in other classes, but if I put in an R value, a 28 R value in a wall system in that design, I have to incorporate that into my building. If I don't, then I have to recalculate and figure out, am I still going to have that same or less or greater or better energy cost calculation at the end of the project? Because you're going to do a calculation at the beginning and you're going to do one at the end that says this is what we did. And so now you've got a comparison in that process. Same thing basically applies when you go to the performance calculation, right? We're going to do the same thing. It's going to be not necessarily dollars and cents, but performance calculations analysis is going to take place to compare our reference design and our proposed design, and how do they match and do they meet. So again, we've got some technical documents to assist with understanding the compliance paths. We've got the trainings. If you have any questions, feel free to let us know. But that's really the overview of the compliance paths. And in those compliance paths, we address all of these different calculations, all these different components. And again, and like I was saying earlier, there are prescriptive components, and then there are also trade-offs within this compliance path, right? And so again, we're looking at, there's literally, I think, 5 to 6 different options. And the state even identifies, again, additional methodologies that we could utilize to identify compliance. But we have to declare what that is, because that's going to drive plan review, it's going to drive inspections, it's going to drive all of that. And so another question is, does ComCheck work for the different paths? ComCheck is one of these systems that can be utilized depending on the process. Now we've gone through ComCheck. The state has worked with DOE and PNNL to develop a Minnesota-specific ComCheck variant. We've done our due diligence, our best. We've run a couple projects through it, and it seems to be operating efficiently and effectively now. So we're good with it. But yes, you can use it in some contexts. And we're going to have a ComCheck basics class here in the future as well. But ComCheck is really that method, is one of those methodologies of explaining how we're going to be approaching the trade-off compliance path, right? I can build a building that says, I'm going to take my tables and I'm going to build a certain way. And then I'm just using that table prescriptively. If I decide to use ComCheck, ComCheck's just doing all the math associated with UA calculations and runs it as a total building so that you can have that trade-off variable, right? So you're not running each one individually. You can do all the math to associate it. And it sometimes is a little bit faster and easier to understand. It also incorporates the mechanical components and the energy components. So you get a full report at the end. So again, I just threw these slides in there. So if you have questions, you can read them about what is the compliance, how we're comparing energy cost projects, what are the minimum expectations, what do the reports look like, again, all that kind of thing. And again, looking at that side-by-side comparison of how much is this building going to operate as designed in my proposal and as it was designed, as it was referenced in the standard. And so as long as I have at least, a $0 difference and I'm not worse, then I can pass. And so again, this $8 difference between operating expenses for these two buildings allows that building to move forward. And again, a couple slides just to help you if you have any questions about the energy rating process, a variety of different rating authorities, expectations, minimum expectations, and again, the reports that you would generally get out of that. Again, broken record, you can still use these. We need to confirm all the details that we have in the plan against what's on the building. That's kind of where we're getting with this, why we introduce these concepts and then talk about it in the Devils in the Details series, because we put these things into a plan, but we have to make sure these are on the actual construction plans, right? And that's one of those things that always gets somehow missed or sometimes gets missed. But remember, the buildings that we see every day, we use wall systems to separate the exterior environment and elements, right? In the building code, we call this an exterior wall envelope. In the energy code, and again, we're separating exterior elements from the interior conditioned building. In the energy code, we call it a variety of different things because we're including what we may be calling semi-heated spaces, right? We're no longer just looking at separating the environment from the occupiable space, but now we're looking at how do we regulate conditioning within that building. So we're going to have the exterior building envelope is going to actually be that place where we separate conditioned space from unconditioned space with inside the exterior envelope, is that the wall envelope. the reality that I see too much is that we use these terms and then all of a sudden we get confused as what we're talking about, which is why the code says we should designate and list these concepts clearly on our plans. And again, there are certain expectations and mandatory provisions that apply in all the compliance paths again, and that's where those tables take us back and say, okay, here's some expectations of every building, regardless of whether or not we use the energy costs or we use the prescriptive processes. And those mandatory provisions are listed in the code in section 5.4. I'm gonna try and go through this real quick. Remember, when we talk about a building, we're looking at what is that thermal envelope, and is it going to be the wall? Is it going to be synonymous and contiguous, a component of the building wall envelope, or is it going to be separating these individual spaces? Right? These are calculations that really become important when we start to think about how a building is going to operate. Are we going to have different HVAC systems? Are we going to have different, occupiable spaces within this design? Because what we see happen too often, if we don't think about air barriers and isolating and managing moisture accumulation within these concepts, then we start to see failures, right? If we have a 3-story building, let's say this is a 3-story occupied residential building, just like we're seeing here, 2-bedroom deluxe, 2-bedroom plus, and this unit is, we take it back one step and we say, this is the building thermal envelope, then if this unit becomes vacant, then this lower unit will actually not only heat its own space, but heat the space above it, right? There's no separation between the two different occupied spaces. And so you're going to have that heat transfer that takes place. So the question is I don't know, this my mouse is really driving me crazy today. Sorry, I'm in New Mexico doing a training, so I'm in a hotel and I don't have my normal mouse, and so the computer's driving me crazy. The question in the chat is, so ComCheck cannot be used to indicate compliance for a design under the performance path. A different software is needed. That's generally correct. Generally correct. Now there are, and I've not looked at Minnesota's version of ComCheck. Some states have asked ComCheck and PNNL to provide a energy cost alternative in addition to the general role of ComCheck in creating that building trade-off path. So I'd have to double check, but for the most part, you're going to be looking at a system like an Ecotrope, a rim rate, a Open Studio, another software that's going to calculate the energy cost, and again, there's a lot of variables that go into that when you calculate energy cost and performance values, because you're looking at you're going to evaluate the consistency and location of your thermal envelope so that you can determine what are my zones and what's the real potential of a zone going to be occupied versus unoccupied. I'm working on a police station project where their argument is, depending on the number of officers and individuals in the building at the time, we may have different zones operating at different peak efficiency, peak demands. And so because of that calculation, they had to run multiple energy analyses. And again, that's the reality of doing it, an energy cost calculation. You're going to have to look at all those calculations. When is the building going to be occupied? What are the peak loads? How many people? Where are they going to be located? Where all these components get pulled out, and not to make it sound too crazy, but that's what we're looking for, is what are all those components, and then that software is going to do that analysis and say, here's the rate, energy rates for whatever the equipment might be, calculates those loads and those costs. So again, it gets a little bit more not complicated, more detailed in how that building's going to operate. But yeah, and generally, that's not what PNNL or ComCheck was designed to do. It's designed to say, this wall system with this insulation matches or meets the expectations of the code. This piece of equipment, it doesn't evaluate if it was appropriately sized. It says this piece of equipment, based on its output, is efficient. It meets the efficiency requirements of the tables. Same thing with energy calculations. It says this design with these fixtures, with these specific number of fixtures and lighting components and in controls meets the power allowances associated with the tables for that design. So again, it expedites the process of doing that design, but it's not the same as an energy analysis 90% of the time. So again, it would have to double check with, and we can look into that and get that out as an email to everybody. But again, we'll be doing some more detailed deep dives into the different compliance paths and the comp checks and the res checks when we get to it, because they're very useful tools. And as building officials, there's that, we need to understand what is being provided to us. It's not that the building official is, I did a 4-hour class for the state of Maine on ComCheck because they wanted to understand the process. How does it work? And then also, as we do with all these classes, we integrate building officials and design professionals. So again, we can, if you have specific questions, always let us know. And we'll do more classes to provide that extra detail. And we'll also have some technical documents that explain what is submitted in those processes. But from a design perspective, we're looking at what zone am I located in and what is the different space types. Again, am I going to be looking for, traditional conditioned space, residential space, conditioned space, semi-heated spaces? Again, if you're going to have spaces that are going to be heated, they have to be designated and approved, right, by the building official, so that the building official knows what's going to be semi-heated and what's going to be unconditioned. And then we're going to have some form of documentation, right? We have to specify where these elements are within our building so that we know what, when we go out to do our inspection, when we go out to verify our air barriers, we know where they're at. Again, if I just go with this willy-nilly approach to, well, anything on the exterior wall, I'm assuming, and then that's my key phrase. I hate the phrase assume. If I don't have proper details on where that air barrier is going to be, and I assume the exterior envelope, wall envelope is where it's going to be, then I'm going to incorporate ventilated and unconditioned space that isn't going to properly control heat transfer, right? If I use this example that we see on the screen, this ventilated attic is allowing, a ventilated attic is going to allow air, exterior, unconditioned air into the space. If I am not incorporating my, if this wall, these series of walls between the semi-heated and conditioned spaces do not incorporate my air barrier, then I'm going to lose air to that unconditioned space in the ventilated attic, and I'm going to have heat loss, uncontrolled heat loss. Now, am I going to be able to completely restrict heat movement? Maybe not. But again, that's the point, is I can control what I can lose. Similar to this ventilated crawl space. If this is if the air barrier is not separating my conditioned from unconditioned space, then I'm going to be losing heat through that process, and my calculations and my expectations for that project are going to go out the window, just like my heat or cooling. So again, isolating, identifying those components, where that heat, where that air barrier is supposed to be, is critical to making sure that we have a proper thermal envelope. Here's another example of just a cut sheet that comes on a project that we did, where again, they're providing this line to tell me that this purple line that you see everywhere is their air barrier. That way I know where it's going to be, I know what I'm looking for, and also we can evaluate what material is being used to provide it. Again, mandatory expectations of the building thermal envelope include insulation, fenestration, and air leakage, right? So we're thinking, what's in the wall, what penetrates the wall and fenestrations, as in doors and windows, and then how does that whole system control for air leakage? Remember, that's the thing. That's what we're looking for. Where is the air barrier? Where's the thermal envelope? Where's the air barrier? And then what makes up that system is what we identify. What components are involved in delineating that thermal envelope? Again, we go back to, are we looking at roofs, walls, floors, slabs? And then what does the table tell me I have to do? Now, if there's one thing I know, at least from me and my family will tell you, it's all about Insulation, insulation, insulation. Now, I put that picture at the top because it's all about Marcia, Marcia, Marcia. And in 90% of our conversations on the thermal envelope, we say it's insulation, insulation, insulation. There's a variety of materials that we can use to insulate the walls, and everything begins and ends with the thermal envelope, right? But insulation can't work alone, right? Insulation slows the transfer of heat. It's the air barrier that works in concert with that insulation to restrict airflow completely. Again, we use the example, and I think I've got it in here, of air barriers, cannot be an afterthought, because whether it's a small leak or a big leak, that air movement is going to have consequences, right? It's going to reduce our efficiency it's going to reduce the efficiency of our insulation. It's going to allow for vapor water transfer. It's going to incorporate, or going to again allow for pollutants, pollens, and different things that may affect how an occupant of a building operates. Again, if you have allergies and you're used to a building that leaks, has a lot of air leakage, then you're going to be affected by that pollen differently, and that's going to affect productivity within a workspace, as well as smoke, smog, and exhaust. Now, one thing I will be honest, when I worked at City Hall, we had a plaza beneath us that they always had barbecues. And you know what? The one thing that really stunk was that we'd had good thermal envelopes and air barriers, because when they were down there grilling, I couldn't smell a thing. But the moment I stepped out the door, it was like heaven, right? Grills everywhere, and you could smell the barbecue. And while that was demeaning to me and more demoralizing to me to know there was ribs downstairs that I wasn't enjoying the smell of, it really made that building operate more efficiently when it came to how much time people could spend in the office, right? We weren't worried about some of the health effects. We weren't worried about the heat loss. We weren't worried about some things, because we had a building that was built with a proper mind towards air barriers and insulation. Remember, air barriers work just like that coat. The thermal envelope as a whole works just like a coat. There's insulation, which is that nice thermal jacket that we wear at the beginning of October, right? That we can get through a couple months. And then at some point in the winter, we're going to throw on that air barrier, right? That air barrier, when I wear my insulated jacket, I can survive, right? I can go to the ball game. I can sit outside and watch a football game. But if it gets super cold, I'm going to the air barrier jacket. I'm going to an insulated jacket that prevents the heat from leaving my body, leaving my jacket, and traps it within. And most of us who've been in one of these parka type style coats knows that once you go inside, if you don't take that thing off quickly, you're gonna sweat to death, right? Because it is trapping all of that heat inside that envelope. And the same concept applies to our building. We're going to have insulation to slow the heat, and then we have an air barrier to try to really restrain it even more, so that we control everything that exists within our buildings. So I've got a lot of slides and probably not enough time. We're not going to go through it all, but again, how does the air barrier work? Again, it resists heat transfer through the insulation, but again, and then once that heat or air moves through, so if we have air permeable insulation, insulation that allows air to move through it, it will slow the process. But when it hits that air barrier, then it stops air movement, right? It's all about the difference between air barriers, air and insulating components. Not all insulation is equal. Some is designed with chemical capacities to provide continuous insulation to serve as that. Some of this can be, from a design perspective, understanding that we can use a material to perform both as insulation and as an air barrier, as long as we follow the appropriate installation instructions, right? We're not only providing thermal bridging, thermal separation, so that if we see the impact of this 2x4 on heat transfer, and not that we're going to get into thermodynamics, but again, or thermal values, we'll talk more about insulation in our next training. But in the air barrier concept, any heat that's being transferred by the air that comes to this element will now dissipate and go into the ether, go into the air, right? Because there's no barrier that exists. Whereas if we have a barrier, any air that actually makes it that far will then be stopped because that barrier is going to resist air transfer through it. Remember, there's a variety of materials. Not every insulation is the same. So again, if we have a low density spray foam, we may have to install it at a greater depth of or thickness because it's not designed, it's open cell, it's not designed to stop air at the same rate as maybe our medium density closed cell spray foam. The air permeability rate, when we compare these two and the way they're designed, the way they cure, we're going to need 4.5 inches on average of open cell to create an air barrier, right? We're going to need 1.5 inches of air cell of closed cell spray foam to get that same air barrier because it's designed and cures in different ways. And again, with new technology, how long it will be even shorter term before we get new chemical makeups that provide even greater levels of insulation and air permeability. And again, the code provides for us a variety of materials that also serve. And here's an example here. So on a closed cell, 2 pound, so a closed cell medium density spray foam is at minimum 1 inch, provides us that air leakage barrier. So again, different materials, you have to look at the actual material. It will tell you at what level it provides that mandatory level of air permeability for your air barrier. But you can, again, use these systems in context, fill voids, do all kinds of things. And again, what we're trying to do is create a barrier to air transfer so that when we open up a cavity, we don't see what we see here, right? This is air permeable insulation, and that dark discoloration is not mold, it's dirt, right? That's moved in with dust, that's moved in with pollen and other things. And once it gets into those spaces, it gets caught in that material and then fills up the voids. By increasing by providing that air barrier, we're preventing that air movement from making it that far. And so again, air barriers are just like a lot of different water resistant barriers. They're going to allow air flow to some degree or restrict airflow. So not every barrier is the same either, right? Water resistant barriers are not necessarily always the air barrier. You need to think about how are those systems providing for air transfer. What was, and what's the relationship between the two as we think about what we're prescribing and what we're seeing on the plant, what we're designing for, and then what we're inspecting in the field. If I know this material is what I'm looking for, then I go in the field and I find it, I know what I'm looking at. If last minute changes take place and I need to make sure these materials equal or comply with the expectations of the code when it comes to air permeability rates. And again, the major thing to think about when we think about air sealing details is following the manufacturer's installation. If the manufacturer says, do it this way, that's the way it needs to be done. They're the one who designed their product. They know how it operates best, how it's designed to operate as an air barrier versus a water resistant barrier. We use Tyvek as a good example, and that's one system that when you look at it, it says, the one application I had, it says you have to apply it with a 6-inch overlap, and that's your water resistant barrier. And then it says, but if you apply tape to that seam and properly tape it and seal it, then it's an air barrier. You didn't change the overlap, you changed the sealing component, the taping of that seam. And so again, what is that system doing and what is it providing? It's really the calculation that we start to ask. Now, there are certain design requirements in the energy code, and they're found in these 3 places. Now, remember, I'm going to give you this handout at the end, so you don't have to, hopefully maybe you write it down, you screenshot it, but again, it's in the code, and we want to make sure that you have everything you need when it comes to understanding how the code operates. Now, again, these webinars will be available for you to look at later once I get all of them uploaded to the system. But again, we're looking at what's on the permit document, what's in the expectations for air leakage, what's in product installation. Those are the 3 places where you're going to find air barrier details or recognition of the importance of air leakage details. So again, the application requires that the application provide air leakage details. So again, you're not asking for anything that's not required. So as a building official, I'm not asking you to do something different. I'm telling you this is what the code says. I need to have is documentation on how you're going to control and test for air leakage. We can actually go to the actual, so that's in the permit side of the process. And then when you go to the actual mandatory provisions, we see the expectations, the list of components that are identified. What are the exceptions? Well, there are no exceptions. In its adoption, the state removed the exception number 1, and number 2 doesn't apply because we don't live in climate zone 2B. And so again, the exterior barrier shall comply with sections 5.311 and 5.312. Now, what that means is that we're either going to comply with whole building air leakage testing and performance verification, or and we're going to be looking at the continuous air barrier design and installation, right? We're going to have expectations on how it's going to operate, how it's going to be installed, and how we're going to test it. And so when we think about that in the context of the building, the whole building test tells us that we have a certain air leakage level and that we've got to meet it, and that it allows us to show those spaces when we have conditioned and semi-heated spaces, either to show them together or separately, right? So depending on what we're looking at, we can test the semi-heated components or area different or separately from our heated areas. And again, the reason this is important, the reason I bring this up is not only because it's in the code, but also because it really drives at what information is provided. If I don't know where the separation exists, then how do I know what to test? How do I know where to expect, what to expect? Am I getting 1 report, 2 reports? What are the thoughts? How are these things going to be tested? When's that test going to be identified? So the term normalized here, when it talks about it really means average, right? When we talk about testing, we're gonna have them averaged to account for the fact that they could be different spaces. And again, same thing here. When we're talking about normalized, as they're doing it together, we're going to understand that they're going to be looking at the area of the building thermal envelope and the semi-exterior building envelope, right? We're going to be looking at the semi-heated and the heated combined and then averaged when it comes to their calculation. We're expecting to have that, again, in our verification documentation on our permit. We're going to be expecting that these records be provided not only to the owner, but also to the building official. Again, we need to know, is this building going to perform as it was designed? And we know that the code provides a series of exceptions to help us in understanding whole building air leakage testing. And that includes, for buildings over 50,000 square feet, an area weighted evaluation where we're looking at the series of components, right? We're looking at all those elements that are directly under the roof, those that have entrances or loading docks, those floors, the entire floor of that story, the entire story. You know, if you think about it, if those of you that may be familiar with residential, you're looking at units that exist in those spaces. In commercial, we're looking at the entire floor, right? And again, if this building stepped down and there was a second story, we have a 6-story building, and then we're gonna have a 3-story section next to it, then that top level is again under roof and it would be required to be tested as well. And then what we're looking for is 25% of the remaining floor space, right? So we're gonna do the top floor, anything under a roof, anything with a building entrance, and 25% of the rest of the building to determine, is this, in lieu of a whole building test, this is our alternative, right? And again, the building and definitions matter because again, we're talking about a building entrance is used to gain access to the building or to exit from the building, right? So again, understanding what we're talking about when we come to the context of what we're testing. So you're gonna have to pay attention to that when we start to think about from a design perspective, where you're putting all these access components. So if you're putting buildings on hillsides and then you're gonna have extra accesses, then again, you're now bringing that element, that entire floor into the requirement for compliance for air testing under this alternative. Oh, had an extra steps. One of the other exceptions that are identified allows for a diagnostic evaluation of the air barrier utilizing new technology. Now, we've been talking about a lot about, internally in our offices about thermal cameras and how does that assist. And what you're looking at is you're going to do an inspection that verifies that you did some level of air leakage testing, but you weren't perfect. You didn't hit you were between that 0.4 and 0.6 CFMs. You're going to use thermal imaging or smoke tracing to identify potential deficiencies and then do a report that identifies what you did to correct them, right? So you're going to have that report. The report doesn't tell us exactly what's supposed to be in there, right? Just that we're supposed to put the corrective actions. I typically have expected when if I've talked to people about it, I want a before. I mean, the technology is there, and I want a before of what made you identify that as an area, and then what it looks like after. Can you lie to me? Yes, but at the same time, if you're going to take that much time to lie to me, you probably deserve to win, right? No, I'm just kidding. Don't take that personal. But again, that's the reality, right? We're providing alternatives that say do the whole building, do sections of the building. If you come close but not quite there, you can go through this extra additional inspection process so that you're not retesting the building a third or fourth time or what that may be. And the third option is then again, are we going to allow for you can have verification by a third party independent third party, right? So if you develop a program for that, then again, you can utilize that as well. And again, that inspection is going to include, again, a design review to verify that the components are going to be installed, an actual periodic field inspection to verify they were installed properly, and then a report that's sent back to the building department. Now we understand that that there are certain expectations when it comes to air leakage, but again, we need to know is on the plans that we're all aware of the same thing. And so the normal building is going to be tested at that 0.4 CFMs. If it's a group R or group I occupancy within that building, it's going to be a 0.30. And it also, again, provides a different pressure differentials. It also provides a different set of alternatives when it comes to how, if you've got a larger building with 8 or more units, then you can do 20% of those units or 7 units, whichever is greater. And it tells us that they have to have, again, a unit that's under the top floor, a ground floor unit, a largest unit. And it tells us that, again, it's this different in that it's not the entire floor, it's just an individual unit. Because, again, we're expecting that if this unit becomes vacant, that the air barrier associated with with the unit in orange needs to be effective, right? And if we're randomly testing these areas, then we can verify that the method of installation was adequate for our air leakage expectations. And again, understanding the blower door expectations. What is an unguarded blower door? And making sure that we identify that on the construction documents so that we're not pressurizing. In an unguarded blower door, we're testing just that specific unit. You can test the entire building. You can test just that unit. In a guarded blower door, you are testing the center unit in our image here, but you're pressurizing the surrounding areas. So really, you're not testing that one unit. You're testing its relation, all 5 units in all reality. And so you have a greater potential for statistical variance. I'll call it that, right? So the code says you have to have an unguarded blower door test. What we need to think about when we think about this in the context of our building plans is we need to think about where are these things going to be located. And sometimes those building plans come in multiple pieces. We all have probably done projects where one section of wall is different from another. We're not getting a pretty nicely defined area. And so that's why it's important that we understand where are these components going to be, what material is going to be applied, and so we can make sure it's consistent across the entire set of plans that could be several hundred pages long. Same concept when we talk about what is the weather barrier. And if I go to this detail, which is very helpful to have the details listed, I go to the detail, then I can find out, is this weather barrier able to perform the responsibilities of the air barrier? Or is this just a water-resistant barrier? This one here calls for an air-water barrier that's typical. Well, Is it a water barrier, air barrier, or again, what material are we utilizing? What's the spec on that material to make sure that it's adequately providing the code? One of the things I think is important to understand is where things are located, and that we don't assume certain things. This is one of my personal favorite images, simply because symbology matters to a lot of people. And so the symbol that we see here represents a air permeable insulation for most people in architecture or in design or plan review. However, it's identified as a closed cell spray foam of R38. So now is this my air barrier, right? It's not, it doesn't match symbol wise. So again, this is where we got to take maybe some time and actually, make sure we're using the right symbols and make sure we're paying attention to those materials. And is this identified as part of that air barrier? Because we don't see any other air barrier identified. Similarly, we have some rigid insulation, right? And so is this rigid insulation supposed to, we've got the DuPont Tyvek wrap over the rigid. Well, again, how's the installation, and is that going to be providing just a weather resistant, or is that going to be an air barrier? Specs are important, and I think it's important that we recognize spec books. Spec books are used for more than just holding a door open, but at the same time, we also need to know what we're referencing. This project here had fluid applied weather barriers, as well as in section 7, as well as, again, moisture vapor emission control in section 9. Am I looking for air water barriers? Am I looking for the standard for the, again, what type of material? How are we providing adequate detail to our contractor on what they're supposed to supply to meet the needs of the building? So again, making sure all those things are in there, and that we're not just having a fluid applied vapor barrier at all exposed exterior wall construction, right? What are we expecting, and how are we going to be able to adequately ensure that the project is successful? Again, here's the plane of the air barrier, right? And again, this helps verify what I can test, what I need to test, especially when I think about it in the context of heated and semi-heated areas. Again, 5.2, we've talked about this is also required, and it talks about all the expectations for the air barrier when it comes to the joint seams and all that. And it needs to be clearly defined on the documents. The joints need to be, penetrations need to be detailed so that we know what we're expecting, and so that when we show up to a job site or we see the type of material being utilized to seal a penetration, we can say that's not adequate to resist the pressure differences that exist in a building. So again, if I don't have proper detailing, I don't get proper installation. Same concept when it talks about the extension of that air barrier over all of the surfaces, and that needs to be continuous. And are we wrapping under? We go under this bay window, but we don't go under the soffit. We've got a gap here that exists. Is this my resistive barrier? Again, where are we making sure that these are clearly identified? And then as inspectors, we're going out and verifying. So the question is, how does the 3 CFMs per square foot correlate to the 3 ACH 50? I knew you'd ask that question. We're talking about residential. It's similar to the 3 air changes. I think it's actually, I'm not gonna lie to you. I'm gonna double check that for you and get back to you. The reason it's not 3 air changes per hour is because 3 air changes per hour unnaturally benefits or doesn't benefit, unnaturally harms commercial applications because of the style of the quantity of space usually used. If you have a larger building, you can do the whole volume and you can get your 3 ACH. If you're doing it in an apartment building, you're going to generally have a smaller volume, and so your 0.3 actually is better given the volume of the unit versus a full-size building. But I'll verify that whether that 0.3 and the 3 air changes, I want to think it was 4, but I think that's the intent, is right, that they're going to be the same. I think, and with the ASHRAE standards, it's hard for me sometimes to remember, but I'll get the answer for you. Yeah, volumetric bias. Yeah, it accounts for that, by using the 0.3 CFMs versus air changes per hour. Thanks for the question. And again, we need to think about it in the context of again, stack effect, resisting positive, negative pressures. Again, are these materials that are being proposed and installed meeting that? Now, one thing I always suggest to all my design professionals, I know we just got a few minutes left. I always suggest to design professionals, put in your best 10, your top 10 responses to penetrations into a design document, so that if there is a penetration that's not designed or not intended to be to take place, then someone has a response. So again, that's usually something I try to suggest to every time I talk to design professionals. And again, we understand what continuous means. Again, there's some graphical representations. Again, are we talking about continuous sealant? We're talking about how's that sealant identified, and all these different examples. Is that sealant, going to be applied continuously to this component, but not to that component? What does that look like in the field? When it comes to continuity, we're talking about air versus water intrusion. And again, where do we see these potentials? Again, here's a roof penetration. We've got some sealant identified at both the top and the bottom elements of this flashing. Talk about the air barrier sometimes that. Yep, we can talk a little bit about and so what we'll one of the things that you talk about again with these penetrations is some of them that we're going to be calculating are going to be specific devices. If you think about there are different electrical components, the code identifies components, recessed lighting, elements like that can be incorporated and properly designed to be not only IC rated for the context of contact with insulation, but also providing that air barrier. So you need to make sure that the equipment you're calling for incorporates that, or else you're going to have air leakage. It's going to be effective. One of the things we did this week, I've been driving around New Mexico, doing some visual inspections using thermal cameras as part of this concept. And that's one of the things you see. You see receptacles light up like a Christmas tree because they didn't think about the air permeability of those materials, and they've penetrated the wall and not thought about sealing that box properly. And again, there are different types of boxes and epoxies and putties and all these different things. And what you're really doing is you're giving information to that designer, as a designer, you're giving that information to the contractor to make sure they have the tools and the information they need to do it properly. Let me see it. I know we got a lot of slides. I had way too many slides when we talked about barriers, cavities, seals, joints. Talked a little bit about loading, or intended to talk about loading docks, what those look like. I probably put way too much into this as far as what we could cover and accomplish. Again, what are we thinking about for vestibules and revolving doors, and identifying those areas, identifying the space, understanding the calculations, the wall systems to make sure that we're protecting them against air infiltration, exfiltration, identifying the acceptable materials that can be utilized as part of that 5.8, where we talk about materials that are deemed to comply based on their construction, which is again our 13 items of materials that are identified and our 2 items assemblies that are identified, and what are those expectations, and how you could maybe have some field verified air leak fenestration leakage controls. The one thing that we see that's not listed again, like we talked about, is Tyvek, because Tyvek can be a water resistant barrier given certain expectations. But then if we're going to talk about using it as an air barrier, we have different expectations on installation. So making sure that we know what's required is important, because installation is key. Let me get to the end. I had a bunch of examples. I apologize. I'll send you a list of all these examples and all that. But most importantly, just remember we meet on the 1st and 3rd Thursdays of every month. We're going to be looking at our next one in August the 1st, and it's going to be on insulation design. Again, if you have any questions, check out our website. You'll find some different information. And again, if you're interested in registering or participating on the July 31st, not June 31st, July 31st training in Monticello, please reach out to us. We do have the code helpline. If you have questions that come up You feel free to input your questions into our code helpline, and a subject matter expert will respond back to you. If you have any questions, feel free to reach out to us. Again, I will put a little bit more narrative with our PowerPoint slides that I send out as your handout. That way, those slides that I ran through as far as those examples, you can have some context for what those examples look like. But again, really the point is air barriers are important details that we need to make sure are properly and adequately and consistently detailed, because they're going to affect the building's performance in a variety of different ways. So I appreciate you listening. I apologize. I put too much. I put 10 pounds in a 5-pound bag. But again, hopefully you'll join us again next week or in 2 weeks, or however many weeks it's going to be, 2 weeks, when we talk about insulation. So you guys have a great day. And as far as the question here, does contract have to be signed off by a professional? No, it can be. It's designed by whoever wrote the system. So you don't have. There's not a licensing credential that goes with it. So it's just you're verifying that that was what was placed into the calculation. So you guys have a great week. I'll be sending around your information. If you don't have your DLI number and it's not in the survey, please use the survey. Or if I don't have it, I will send you an email and you can respond back with your DLI number. You guys have a great day, and we will see you soon. I'm going to stick around for a little bit for those who may have questions, but you're more than welcome to leave.